All right, welcome to trigonometry. So this is going to be our first lecture here. Um, First thing I guess we ought to do is talk about what we're going to be studying, which is angles. Actually, triangles, really what we're studying. But the first idea of this class is to start going in about angles. So let me go ahead and turn my attention to my little board here. So I'm going to be turned away from you, but looking at this board over here. So I'm hoping that's not too distracting. Um, but we're just going to start talking about angles here. Okay, so let's go ahead and start with this. So as we have an angle, we'll go ahead and we'll just make a little angle here. And what I'm going to do is I'm just going to label some points here. I'm just going to say this guy here, we'll say that's B. This angle here, this point here will be A rather. Okay, and then this point over here will be C. So this angle here, we have what they call an initial side. Okay, and we have a terminal side. Okay, and then down here, we're going to have what they call the vertex. So A is my vertex point, all right? And the way we're going to reference this angle, okay, is we're going to say angle BAC. We start from an initial side. The vertex is always the one in the middle, and then C is generally, the terminal side is generally your last letter here. So that's how we go ahead and um, reference this angle. Okay, so that's kind of what we do this. We usually give it a name. Okay, we usually put a little arc here to say it's an angle. We'll usually name these things, and angle names are usually Greek letters. So angle names are Greek letters, generally. Okay, and you know how in algebra x is like every variable is called x? In trigonometry and geometry, it's kind of the same way, except with Greek letter. And the typical name for an angle, just like x is the typical name for a variable in trigonometry, we're going to do theta. Okay, so that's a Greek letter. It's called theta. The way I draw it is kind of like an O with a little loop through it. Okay, and that is generally how we're going to reference our angles. We also, so we have like that's typically your x. Less common, okay, is going to be phi or phi, depending how you want to pronounce that. If it's phi theta kappa, then we go with phi, but I usually pronounced it phi, but whatever. And then there's a couple other ones. So we have A, alpha, okay, B, beta. It's just kind of a B with a long stem to it. So that's beta. And then we have gamma. Okay, that's our third letter in the Greek alphabet, which is a kind of a thing. It's kind of like an alpha turned on its side. Okay, that's kind of what we're looking at for that one. Okay, let's see, gamma. Okay, so that's kind of how we're going to reference our angles. And then we have something called standard position. Okay, so we have standard position. And when we start with a coordinate system, right, the typical Cartesian coordinate system that you've known and loved since you learned about it in elementary algebra, usually our standard position is going to be the initial side is going to be the x-axis. So this is often the initial side. Okay, it doesn't have to be, but in standard position it will be. And in our terminal side, so we're going to rotate. So an angle is a measure of rotation. And then we're going to have our terminal side sitting here, and this will be our terminal side. Okay, and this is an angle that's in standard position. We started from the x-axis and we went in a counterclockwise direction in order to measure our rotation. Okay, and that's pretty much what we're doing with that. Right, so let's see here. Go through this. Okay, trying to get page 2 for God's sake. There we go. Okay, now we have two different types of angle. We have two different measures of angles that we can go with. We can have positive rotation, and of course, we can have negative rotation. So positive rotation is kind of counterclockwise, right? So if I go ahead and start with my X, my Y here, we start here, we just start rotating over. This will be a positive degree. So whatever theta, whatever my angle is going to be, it's going to be a number that's greater than 0. We've gone counterclockwise. We could also go in a negative direction. We go ahead and put those in red, okay, like accountants do. So negative numbers are in red for them. So we could also we can go clockwise, and then whatever angle that this is going to be, we'll say that's phi, that's going to be less than zero. It's going to be a negative number for our angle there. Okay, so I'll go back to blue here. There we go. All right, so that's positive and negative angles. Again, we started in the standard position where the initial side is our x-axis, our terminal side is wherever the rotation lands us, and that's kind of where we are with this thing. Okay, so let's see here. Uh, there's a couple of different ways we can measure angles, and we'll get to that in just a moment. But the big thing that we want to learn about for measuring an angle is something called a radian. Okay, and almost all, well, not almost all, many times, angles in trigonometry, especially and angles in calculus, are almost always expressed in radians. Okay, and what the heck is a radian? Let me tell you. Okay, so we have radian, we'll have a circle. Okay, we'll say pretend that's round. And we're going to say a circle with radius of 1. And I would like to know, what is the circumference of this circle? Right? What's the distance all the way around the circle? We're going to say, okay, well, circumference is equal to 2 pi r. Since r is 1, my circumference is equal to 2 pi times 1, which is 2 pi. So one full rotation around the circle is 2 pi radians. Now, normally we don't write a unit for radians. When we do write a unit for degrees, we don't write a unit for radians. Okay, so we're just going to say the distance around is 2 pi. We just know that that's one rotation around. So we're going to say that 2 pi, and I'll put radians in parentheses here, because again, we don't normally write radians, and this is equal to 360 degrees. I'm going to divide both sides by 2 pi here, so we could say divide by 2 pi, divide by 2 pi. Okay, so we could say that 1 radian. Okay, let me go ahead and see if we can. There we go. 1 radian is equal to 360 divided by 2. We'll say that's 180 degrees divided by pi. So 1 radian is equal to 180 degrees divided by pi. If you take the engineer's way out and say pi is approximately 3, which is what I'm going to do, we'll say that this is approximately, we'll say approximately 3. So we know that 1 radian is approximately 60 degrees. It's actually 57 point some change, okay, degrees, okay, because pi is 3.14, not just 3, okay? So it's a little bit smaller than 60 degrees, okay? But 1 radian, about 60 degrees. We can go the other way around, right? We started off with, we have 2 pi, well, let me start on the left, so we can say we have 360 degrees is equal to 2 pi. And again, I'm going to put radians here in parentheses for the first couple of times we're going to do it. We'll divide both sides by 360, divide both sides by 360, and we'll say that 1 degree, notice I put the degree, every time I use a degree, I put the little degree symbol because it needs that unit, because otherwise people won't know. All right, so we can say that's going to be pi over 180 radians. Okay, so we have 1 degree is equal to pi over 180, and that's pretty much how you're going to deal with your conversions. Now, I will say this too. Everybody who has ever taken trig in the 20th century, the people who grew up on degrees, it takes about 2 weeks for people to start getting used to using radians over degrees. So we're going to do a couple so we can kind of see what's going on with everything. But I will tell you that it takes about 2 weeks for people to learn how to use radians and to start being comfortable with them. So as you're going through your homework and you're trying to figure out converting between radians and degrees, and you're getting a little bit frustrated because like it should be easier. Like, no, it takes about 2 weeks for everybody that has ever taken trig to start getting used to the idea that we're going to use radians over degrees. All right. So just be patient with yourself. The best way to go through this is do lots and lots and lots of example problems that we're going to do in just a moment here. But that's what we have here. Okay. In your calculators, usually you have a DRG button. So this stands for degrees, radians, and gradients. You say, okay, well, I've never heard of a gradient before. Like, no, you haven't. So Gradients were really popular right after the French Civil War or the French Revolution, okay, back with Napoleon and all that, when they started getting really excited about the metric system and the idea that a gradient, so with degrees, right, we have 90 degrees here, okay? We'll do this in a minute with a 90-degree angle is also pi over 2 radians. And in gradients, that 100 gradients is 100 gradients. So they kind of took the circle and they said, okay, there's four. What is this 360? Like, where do we get that? That's from ancient Babylonian stuff. Uh, we're going to, because 360 is a convenient number because it's divided by like 36 is nice because it divides by 2, by 3, by 4, by 5. There's by 6. There's lots of ways that you don't have to work with fractions or repeating decimals in order to figure out like fractional parts of 360. It just divides very evenly. The Babylonians liked not having to deal with repeating decimals because they didn't have that as a system. So they made a number that was really easy to divide by a lot of stuff. 360 is where it is. Okay, there's other reasons why they pick 360, but that's the big one. All right, so that's what they do. Gradients, they said, we don't like 360. That's an inconvenient number for metric. We like 100. That's the best way to go. Well, okay, that's debatable, but there we go. So we're going to say 100 gradients is really 90 degrees. And that's the story behind gradients. So if you are writing your historical fiction, and your protagonist happens to be a French artillery officer right after the French Revolution, to give it your air of authenticity, of historical accuracy, that French artillery officer will speak in gradients rather than radians. That is your only practical application for gradients. Okay, we don't use them. Nobody used since the French Revolution. We looked at it, we said, we don't like that system. The divisibility is kind of a nice thing. We're going to keep it, so we're going to keep the degrees the way they are. You can take your gradients, and no, we're not going to do that. Okay, so that just isn't a thing that happened for angles. We don't use gradients, but that's what the symbol means. That's where it comes from. Okay. The other thing that we deal with is that we use degrees, minutes, seconds. Okay, so a lot of times if you have a measure of an angle and you've got partial degrees, they're going to convert them to minutes. And the conversion factor is, well, how many minutes are in an hour? There's 60 minutes in 1 degree. The seconds, how many seconds are in a minute? There are 60 seconds in a minute. Okay, the way that this came from is that the people that would look at the night sky back in the past, they would pretty much track the movement of an astronomical body, and they would time how long it would take that to move. And if it moved like a little bit, they would say, okay, that had 1 second of movement, which is a measure of a rotation because it's what they're watching it move across the sky. And that's pretty much how they were doing this. So that's where that comes from. The fact that it sounds like time is because it is based on time. All right. So that's what we do for that. And we'll do a bunch of examples of converting degrees, minutes, seconds to degrees, and degrees to degrees, minutes, seconds, to radians, to degrees, and degrees to radians. We're going to do a whole bunch of examples for all of that. Okay. So we'll just start off with a whole bunch of examples. And we'll go through and do this. So what if I have to convert 42.5 degrees to degrees, minutes, seconds? Okay, so we're going to convert to degrees, minutes, seconds. So the 42 degrees, I've already converted it. So that's going to be 42 degrees plus 0.5 degrees, and I've got to change this into minutes. So 0.5 times, there are 60 minutes, okay, to 1 degree. So we're going to go ahead and say, okay, what's that going to look like? So 0.5 times 60, we end up with 30 minutes. So this is going to be 42 degrees, 30 minutes. And that's how we go ahead and calculate this out. If we wanted to do seconds, we would write the 0 seconds, but the seconds gets a little double tick, minute gets 1 tick, degrees gets the little circle labeling it degrees. So that's pretty much how we're going to get through and do that. Okay, so let's go ahead and we'll do another one. So we have 18.75 degrees, and we'll see what happens with that. Again, the degrees are already set. We have 18 degrees is 18 degrees. We have 0.75 degrees, and we're going to say we need 60 minutes to a degree. The degrees technically cancel, and we get 0.75 times 60. You'll forgive me for bringing up a calculator. Now, you're not allowed to use this kind of a calculator because it's got way too much functionality to it. You're not allowed to use a graphing calculator for reasons we'll see later. I will use this calculator because I can display it on my desktop for you folks, but I will not use anything that this calculator that you're not allowed to do with your calculator. Okay, so we're just going to say 0.75, 3/4 times 60, and we got 45. Okay, so this is going to just turn into, this is going to be 18 degrees, 45 minutes. Sorry, 45 minutes, just one tick. Okay, and that's what we have for that one. Okay, so that's getting there. We'll go ahead and we'll say, okay, now we'll do a hard one. So we have 73 point, let's go with 284, 284. 284 degrees, and we're going to convert this to DMS. Okay. Uh, for those of you who are like, I've never heard of DMS. The Army uses DMS for its locations. So if you know somebody who's in the Army, or if and they're working with this kind of stuff, they will very typically have used degrees, minutes, seconds for locations and for angles. Okay. Modern times, I think they're the only big institution that uses it. But if you have friends in the military, you want to talk to them, they're going to use degrees, minutes, seconds. So it's good for you to know degrees, minutes, seconds. Sometimes I get my problems out of books that are really old, and they use degrees, minutes, seconds. So we're going to say we have 73 degrees. We have 73.284. The 73 degrees is already in degrees. We don't have to deal with that. So we have 0.284, and we're going to say this is in degrees. We have 0.284 degrees, and we're going to say this is times 60 minutes, and we have 1 degree here. The degrees will cancel, and we're going to go ahead and we're going to say we have 0.284. So we have, what are we doing here? So we have, where are we looking at? We have 0.284 times 60, all right? And I have 17.04 minutes. Again, we don't have to worry about the 17 minutes. It's already in minutes. We need 0.04 minutes, and we're going to say we have 60 seconds to 1 minute. Again, the minutes are going to kind of cancel. We're going to say we have 0.04 times 60, so we have 0.04 times our 60, and we ended up with 2.4 seconds. So in order to say this is 73.284 degrees, say that's 73 degrees, 17 minutes, 2.4 seconds. And there's not a whole lot we can do with the decimal in the seconds except to express it. So when you have this, we're stuck with decimals and seconds. There's nothing else we can do with that. Okay, and that's how you convert from degrees to degrees, minutes, seconds. Okay, you cut out the degrees part, you work with the decimal part, turn that into minutes. You have any more decimals left over, you turn those decimals into seconds, and then that's how you go through and do that. Okay, so practice a couple of those. Let's go the other way. So what if I have 25 degrees, 30 minutes? Okay, we're going to convert this to decimal degrees. Just convert it to just degrees. So again, let's go backwards with this way. Okay, so we're going to start with the 30 minutes. We have 30, and we're going to say this is times 1 degree per 60 minutes. And again, the minutes kind of cancel. So we have 30 over 60. That's going to be 0.5 degrees. So this is going to be 25.5 degrees, right? And that's how we go through and do that. Let's go with this. We've got 12 degrees, 18 minutes, okay, 36 seconds. And again, let's go backwards with this. We have 36 seconds, and we're going to say that we have 1 minute for 30 seconds, for 60 seconds. Okay. So we're going to say 1 minute for 60 seconds. Okay. The seconds kind of cancel. So we're going to say we have 36 seconds times, or 36 over 60. So we'll go ahead and do that. So we have 36 divided by 60. All right. And we have this is equal to 0.6 minutes. Okay. And now we have to move it up. So we're going to add the 0.6 to the 18. So now we have 18.6 minutes, right? Because we went from degrees or from seconds to minutes, and we're going to go from minutes to seconds. So we have 18.6 minutes, and we're going to say we have 1 degree per 60 minutes. We're going to say 18.6 divided by 60. We'll go ahead and deal with that. So we have 18.6. So 18.6. There we go. Divided by 60. Okay. And we'll say, okay, that's going to be 0.31. Okay, so that's going to be 0.31 degrees. So when I'm going ahead and putting all of this stuff in, we've got 12.31 degrees, and that's how we would convert from degrees, minutes, seconds back to just degrees. Okay, so the way we're doing this, you go from the smallest up, you roll your seconds into your minutes, roll your minutes into your degrees, and that's going to be your final answer. Okay, and that's pretty much how you do that. All right, let's think about converting radians to degrees and degrees to radians. So let's convert degrees into radians. Okay, you will get more proficient at doing this. Some of them you will just be able to know on site. One of them specifically, we have 45 degrees. We're going to convert this to radians. Okay, now remember that we have 2 pi radians was equal to 360 degrees. I'm going to go ahead and do it the other way around. I'm going to say divided by 360, divided by 360. So we have 1 degree is equal to, go ahead and deal with this. We have pi over 180 to 180 in order to get my degrees equals 1 degree is equal to pi over 180. All right. So we know that 1 degree is equal to pi over 180 radians. Okay. And again, realize that people will generally not write the unit for radians after the first day that you've done this. And I don't want to know 1 degree. I want to know 45. Let's multiply both sides by 45 and see what happens here. Okay. This is 180, not 100. Okay. So we're going to say that this is going to be 45 degrees is equal to, we're going to say 45 divided by 180 and times pi. Usually we leave the pi by itself sitting there, not always, but I'll show you one of those in a little bit. So we're just going to say it's 45 divided by, so I'm going to say it's 45 divided by 180. I know that's going to be 2. So we end up with 0.25. That's going to be, so we have 0.25, so it's going to be 0.25 pi. Usually we express this as a fraction. 0.25 is 1/4. So this is going to be pi over 4 radians is equal to 45 degrees. Again, this is one of those angles that you will just memorize after a certain point to just know that pi over 4 radians is 45 degrees. Okay, so again, it's going to take some time for us to do that. Okay, so same idea. We're going to convert 150 degrees into radians. Okay, so going back to this, we know that 1 degree is equal to pi over 180. Let's go ahead and just multiply it by 150. So we say 150 times 1 degree is equal to 150 over 180 times pi. All right, and I'll go ahead and do some stuff with the reductions because I want to keep this as a fraction. So we're going to cancel our zeros. We're going to say that 15 over 18. 15 is 3 times 5. 18 is 3 times 6. We can, these are all times, so we can cancel the 3's. So we could say this is 5 pi over 6 radians is equal to 150 degrees. Okay, and that's, again, you'll start seeing these a little bit faster when you do a couple of them. Okay, so let's go ahead and look at that one. Let's look at one that's a little bit harder. So I've got 73.5 degrees, and we're going to convert this to radians. Okay, this is not going to be so much fun. Okay, so we have 1 degree is equal to pi over 180. Again, you can memorize this as a conversion factor. I never have because I just kind of recreate it and say that we have 360 degrees is equal to 2 pi radians, and I just kind of go from there. Okay, so it is a conversion you can memorize. I don't like to memorize, so I'm going to cut down on the amount of memorization you have to do. But that while you're doing these problems, you might want to have that memorized, but it won't kill you to remember that one rotation of a circle is 360 degrees, which is the same as one rotation of radians, which is 2 pi radians. And then you can work through it this way. Okay, so again, we have 1 degree is equal to pi over 180. So we could say 73.5 times my 1 degree is equal to 73.5. I'm going to say divided by 180 times pi. And we'll go ahead and we'll do a calculation for that one because I don't know what that is. So let's go ahead and look at this. We have 73.5 divided by 180. That's not going to be pretty, but that's okay. So we could say, okay, that's going to be 0.40. Okay, well, let's see. That's going to be 0.4083 repeating pi. And since we've already got this messy number, one of the things we could do is just multiply it by pi as soon as I find it. So we can say times pi equals, and then we'll go ahead and we'll construct this to 3 decimal places. So we'll say this angle is also equal to, let's go back to the thing, it's going to be 1.283. And again, I'll put the radians in parentheses there so we know we're talking about radians there. Okay, so here's the big lesson. Radians do not have to have a pi attached to them. Okay, we'll see that in the next set of examples where they just give you radians and there's no pi there. So a lot of times there are pi's, but there doesn't have to be a pi there. Okay, so let's go ahead and we're going to convert radians to degrees. We have, let's go with, we have 7 pi over 12 radians, and we want to convert this to degrees. Okay, again, we know that we have 2 pi radians equals 180 degrees. Let's go ahead and divide both sides by 2 pi. Okay, so we know that 1 radian is equal to, we have, sorry, this is 360 degrees. So we go ahead and divide by the 2. We end up with 180 degrees over pi. Okay, so let's go ahead and multiply, use this as a equivalence equation here. So we could say we have 7 pi over 12 times 180 degrees over pi, and let's go ahead and figure that out. Conveniently, the pi's cancel. It's kind of why there's usually a pi in your radians. Not always, but usually. The pi's cancel. So I've got 7/12 times 180. Let's go ahead and figure out what that's going to do. Okay, so we have 7, let's go with 7 divided by 12, okay, times 180. All right, and we ended up with, this is going to be 105 degrees. Notice the little degree symbol is sitting here now because it's in degrees. I didn't technically write a unit for my radians because we don't usually do that. Okay, so here we go. We have 0.137, and I'll again put the radians in here, but it doesn't need to be there. It's just 0.137. You're just supposed to pick up on the fact that there's no degree symbol. It's going to be in radians. And we'll say times 180 degrees divided by pi, and that'll go ahead and do this. There's no pi's for me to cancel. I'm kind of stuck with doing a calculation here that I actually need a calculator for, as opposed to just being lazy. So we're going to say 0.137, okay, times 180, okay, divided by, and then here's my second function. Where's my pi? Right there. Divided by pi, and we'll go ahead and type that in. And we're going to say that this is going to be 7.8, we'll say 7.85. So equals 7.85 degrees, and that's where we are with this. Okay? So that's where we are with this. And then We'll do one more. We'll say, okay, we have 2 radians. And again, they won't always say radians. They'll just say 2. And we want to convert it to degrees. We're going to say times 180 divided by pi. And that's all we're going to do. Okay, so we're going to say 2 times 180 divided by pi, and we'll get what that is going to be in degrees. Okay, so we have 2 times 180, okay, divided by pi. It's going to be, well, I know that 1 radian is about 60 degrees, so this is going to be close to 120, but it'll be less than that. Okay, there we go. 114.59 degrees. So 114.59 degrees, that's kind of close to 120 degrees, but that's kind of what you're looking at doing here. Okay, so again, don't get too frustrated with yourself. Understand that it takes everybody who has ever taken trig about 2 weeks for you guys to get the idea of radians. I will do my best when we start talking about radians and degrees, we talk about the other stuff, that I will try to use both radians and degrees for a while so that you get used to like the idea between them. So we can make sure that you start to get used to the idea that like 90 degrees is pi over 2 radians. Okay, you'll just start to get faster and faster at doing that, and it'll be a little bit easier. But as many of these conversion problems as you can do to practice is going to make you stronger at being able to do those conversions in your head, and you'll start recognizing what those are supposed to be. So again, don't be too upset with yourself, or don't be too, understand that it takes some time and it takes a lot of practice in order to start getting the idea of radians versus degrees. The frustration you're going to feel is real. Everybody has felt it. So with that, go do your homework. Thank you very much for watching.